Welcome you all. I'm T. Malini, Assistant Professor, PG and Research Department of Physics, Seethalakshmi Ramaswamy College, Trichy, Tamil Nadu, is going to discuss on the topic magnetic levitation. So, magnetic levitation or maglev rings is based on superconductivity because the materials that are employed in the propulsion or levitation of the train is based on these superconductors. So, superconductivity was first observed in 1911 by a Dutch physicist, Kamerlingh Onnes. It is a phenomenon exerted in certain materials at extremely low temperatures, characterized by exactly zero electrical resistance and exclusion of the interior magnetic field. Superconductors are perfect conductors. It is a flow of electric current without resistance in certain metals, alloys, and ceramics at temperatures near absolute zero. It behaves as a diamagnetic below the superconducting transition temperature. The material here analyzed in superconductors are having almost zero resistivity. So next we are going to discuss some properties behind these superconductors. So the first one is electrical resistance. Zero electrical resistance or infinite conductivity is observed in certain superconductors. For example, when mercury shows zero electrical resistance when the temperature is below 4 Kelvin. Next is the effect of impurities. On adding certain impurities to a superconducting material, the value of its critical temperature decreases. So the next effect was observed is the pressure and stress. On increasing it to certain materials like, for example, cesium, it starts showing superconducting behavior, and the temperature of the critical temperature of the cesium is approximately 1.5 Kelvin on applying a pressure of 110 kilobar. So these are some of the properties that are analyzed. So from this graph, you could see it was plotted between temperature and resistance. So for a non-superconducting material, as I am going to decrease the temperature, the resistance correspondingly decreases. But in case of superconductors, as I am decreasing the temperature, the resistance of that particular material gradually decreases until it reaches a critical temperature. At that point, suddenly the resistance drops to zero. So this was analyzed in certain materials, and this property is observed as superconductivity, and these materials are analyzed as superconductors. So next, coming to the discussion of Meissner effect. In the first diagram you could see the magnetic lines of force under normal state. When the temperature is greater than the critical temperature, the magnetic lines of force or magnetic field is allowed to pass through the material. But when the temperature is below the critical temperature, or when it is in the superconducting state, the magnetic lines of force are completely excluded from the superconducting material. So this effect is called as Meissner effect, and the applied field is also below its critical field. So this effect was observed in superconductors, and the effect will be called as Meissner effect. So next, coming to the advantages of the superconductors. So superconductors can carry large quantities of energy without heat loss. It was able to generate strong magnetic fields and have beneficial applications in medical imaging techniques. Superconductors increases speed in computer chips. So as a coin has two sides, there are also some disadvantages observed, and those are listed below. So it is having a low critical temperatures that are to be analyzed are very difficult. So maintaining low critical temperatures are difficult. It is highly expensive. Intensive energy is to be maintained, and it is chemically unstable to some environment. Next, coming to the application. So based on the advantages and disadvantages, we have various applications related to it, that is Maglev trains, magnetic resonance imaging, nuclear magnetic resonance NMR, magnetic confinement fusion reactors, and particle accelerators. So these are the various applications below this, but we are going to just concentrate on what is Maglev trains, or in short it is called as magnetic levitation. So before that, we just make a comparison between the maglev and the convectional train. So compared to the convectional train, where it has wheels and when it runs over the rails, so due to friction, so we should have a continuous monitoring or maintenance is needed for in convectional train. Whereas in maglev trains, since it just floats over with the help of the field and there are no wheels, so no friction, so less maintenance is required in maglev trains compared to the convectional part. In convectional train, fossil fuels are used in engines, and whereas in maglev trains no fuel is required, so no engine, so no fuel is required, and the speed also in maglev trains is greater compared to the conventional train, that is greater than 300, nearly 500 and 550 kilometer per hour is also possible in case of maglev trains. So coming to the concept of magnetic levitation, so here the object just floats when it is suspended, or it is freely suspended without any support other than the magnetic field. So such a process or method we call it as magnetic levitation, maglev, or magnetic suspension. So these are the factors that are responsible for this magnetic levitation. The two factors are lifting force and stability. So lifting force is just providing an upward force sufficient to counteract gravity. Stability, it ensures that the system does not spontaneously slide or flip into the configuration. So next, these are the methods based on the maglev trains. So electromagnetic suspension, EMS, or electrodynamic suspension, EDS. So in electromagnetic suspension, it uses the attractive force of a magnet beneath a rail to lift the train up. Whereas in electrodynamic suspension, it is a repulsive force between the two magnetic fields to push the train away from the rail. And the maglev train can travel up to a speed around 500 km per hour. So these are some illustration of the companies or the countries that is using magnetic suspension, Germany, and electrodynamic suspension, Japan's maglev train. So this is just a schematic representation of a maglev train. So this shows that the magnetic pole pieces are arranged on the train tracks and also beneath and in the sides of the train, so that when the magnet or when the train moves over this, we all know that like poles repel and unlike poles attract each other. So due to this, there is a levitation and propulsion taking place in the train with respect to the rail or waveguides. So the like poles repel will push the train upwards, and the unlike poles or opposite poles just attract and pull the train forward. So by levitation and propulsion, the train just floats and moves is actually taking place. So you could see a repulsive magnetic force that is exerted when opposite like poles are brought together. On the opposite poles, you could get an attractive magnetic force. So these are the two types of methods in which the levitation process. So the train moves forward and it is suspended, and levitation and propulsion technique is taking place, and this is a schematic view of how the pole pieces, the North Pole and South Pole, are placed on the waveguides, trains, and how it is attracted and repelled as the train moves over the rail tracks. So you could see like poles are getting repelled and unlike poles are getting attracted, and the train moves forwards with levitation and propulsion concept, and with the support of this field it is able to float over the train tracks. So it is mainly used in different countries. So you could see how fast the train could travel, and so this is achieved in Maglev trains. So thank you all for your patience listening. Thank you.